So now in this video we will see what are the design steps of NFA. So similarly like a DFA, we can design the NFA but with few modifications in NFA. So here every time whether it may be a DFA or NFA, first of all we should understand the long ways of strings. So what is the problem given? In that problem, what will be the string pattern that we have to understand, and now we have to write the set of strings in that long ways from the minimum length string. Every time you have to write the minimum length string. Then we have to draw the diagram, basic diagram for the minimum length string. Then obtain the possible transitions to be made for each state on each input symbol. And after that you have to draw the transition table. Then you have to take some strings and you have to test whether those strings are accepting by the machine or not. And finally write the whole definition of the NFA with the NFA 5-tuple format. So these are the basic steps of designing the NFA. Now we will see one example so that we will get clarity on how to design the NFA. Here I am taking an example. Design NFA that accepts all strings which contains 0, 0 as a substring over the alphabet sigma is equal to 0, 1. That means on the alphabet sigma is equal to 0, 1, I need to draw the NFA diagram. So please once you have to look at the problem. Problem is every string shall contain 0, 0 as a substring. If it contains 0, 0 as a substring, it should be accepted. But we have to draw the diagram in the form of an NFA. So what we have to do? First of all, we have to write the long ways of, as per our, first of all, you have to understand the problem and you have to write the long ways of strings. So here the minimum string is 0, 0. Or you can take 1, 0, 0. You can take 0, 0, 0. You can take 0, 0, 1. It should contain 0, 0 as a substring. Suppose 1, 0, 0, 1. It's consisting of substring 0, 0. 1, 1, 0, 0, 0, 1. It is also consisting of substring 0, 0. So like that you can write infinite number of strings. So that it is called as infinite long ways. Why? Because the number of strings are infinite in the given particular pattern. So that the long ways is infinite long ways. So now what is the minimum string? The minimum string is 0, 0. Now you write the diagram for the minimum string. Let us design for the minimum string. Minimum length string. Let us design for the minimum length string. So what is the minimum length string? 0, 0 is the minimum length string. Here on Q0, on taking the input 0, I am going to Q1. On Q1, on taking the input 0, directly I am going to Q2. So now I am making Q2 as the final state. So this is the diagram for the minimum length string 0, 0. Next after that, write the possibility of transitions. Write the possibility of transitions. That means, so what you have taken on Q0, we are going to 0. On Q1, we are going to Q2, and we are making Q2 as the final state. Let us suppose, this is the initial state. Let us suppose, initially on taking 0, I will be on Q0 only. Initially, after seeing 1, I will be on Q1, Q0 only. But after some 0, I will go to Q1. After some directly 0, I am going to Q2. After 0, 0, I may see either 0 or 1. I will be on the same state. So now here I am stopping designing of the NFA. So in NFA, there is one more point is there in NFA. You are not required to define all the states on all the input symbols. Here I have not defined on Q1, I have not defined the input symbol 1. That means you are not required to define all the input symbols on all the states. And also you can define more than one transitions on one input symbol on one state. That means current state. Here if you see here on Q0, I will be on on taking 0, I will be on Q0 only. On taking 1, I will be on Q0 only. But for one at one time, on taking 0, I am going to Q1. On taking 0 on Q1, I am taking to Q2, and I am settling on Q2 and making Q2 as the final state. Now after reading 0, 0, if any number of zeros or any number of ones, I will be on the same state. So this is the way of designing the NFA. So after writing designing the NFA, you have to write the transition table for the NFA. So how you will write the transition table? Suppose if you see here I am writing the transition table. Now this is sigma, that means it is your input alphabet. Here I am taking the number of states. What are the number of states? Q0, Q1 and Q2. Q2 is your final state. Q0 is your initial state. What are input symbols? 0 and 1 are the input symbols. What is happening on taking 0 on Q0? On taking 0 on Q0, you will be on the Q0, or sometime you may go to Q1 also. Now on taking 1 on Q1, you don't have any state. So here on taking 1 on Q0, you are going to Q0. You can write in the set form, or you can write in you can write directly as Q0. It is enough. Why? Because on taking 1 on Q0, you are going to Q0. So what happens if you take 0 on Q1, you are going to Q2. What happens Q1 on Q1? We have not defined where to go 1 on Q1. So you are not required to write. So here when you define 0 on Q0, you are going to Q2 only. So if you define 1 on Q2, you are going to Q2 only. So this is the transition table for the NFA. So what are the NFA you have designed for that NFA? This is the transition table. Now we have to see whether the string is accepted or not. Now let us take a string. Let us take a string W is equal to 1 1 0 0 1. So here you have a substring 0 0, so that it should be acceptable by the NFA. Now we will see what are the possible ways are there in accepting this string. So first of all, you have to derive all the paths. Suppose initially you are on state Q0. On taking 1, where you are going? On taking 1, you are going to Q0. Only. Again, after taking next one, you are going to again Q0 only. There is no alternative. You are going to Q0 only. After taking 0, where you are going? Either you can go to Q0 or you can go to Q1. That means here the path is dividing. On taking 0, you can go to either Q0 or you can go to Q1. Now what is the next state? What is the next symbol? 0. So what happens? Q0 and 0. Again you have two states. If you consider 0, if you go in this path, you have to consider this 0 on Q0. So either you can go to Q0 or you can go to Q1. So what happens? 1 on Q0, you are going to Q0. 1 on Q0, you are going to Q0. If you go in this way. Suppose if you go in this way, 1 is not defined on Q0. So there is no movement. Here you are stopping. If you take, suppose if you come in this way, so after seeing 1 1 0 again you have 0. So what happens? Q1 on 0, Q1 on 0, you are directly going to Q2. Again, what happens? 1 on Q1, Q2, 1 on Q2, you are going to Q2 only. Now you will check among your, so after reading this string, you have several paths. So if you go like this and you have settled here, or if you go like this, you are here, or going like this and you are here. Out of these, so what is your leaves? Leaves are 0, Q0, Q1, Q2. Out of these, we have to check if any path is leading to the final state. Yes, you are going to final state. Here, this path, if you see here, this path is taking to final state. That means one of the paths is taking us to final state. So that the string W is equal to 11001 is acceptable, is accepted. The string, whatever the string you have taken, so that the string is accepted by one of the paths. So now we can say that the string is accepted by the given NFA. So you have to try all possible paths, and if any path is leading to the final state, then then we have to accept that string. I think you are understanding. Here in NFA, you have more than one path, so that you have to try in all possible paths. If any path is finally leading to the final state, then you can say that your string is accepted. So finally, we will end up with the definition of NFA. So what is our NFA? Our NFA definition is M is equal to Q sigma delta Q naught and finally F. So here in our design, what is Q? In our design, Q is how many states are there? We have 3 states: Q naught, Q1 and Q2. And what is your sigma? Sigma is equal to input alphabet 0, 1. What is your delta? You know, delta is a transition function from Q cross sigma to 2 power Q. So now, what are your transitions? You have to write all your transitions. Delta Q naught comma 0, you are going to Q naught. Similarly, delta on Q naught, 0 on Q naught, you are going to Q1 also. Again, Q naught 1, you are going to Q naught only. Again, when it comes to Q1 on 0, you are going to Q2. 1 on Q1 is not defined. Again, Q2 0, you are going to Q2 only. Again, delta of Q2 1, you are going to Q2 only. So these are the possible transitions made in the given NFA. Next, Q naught. Anyway, Q naught is the initial state. Here, initial state is your Q naught only. Initial state. That is Q naught only. Next, final state. What is your final state? Final state is, here you have only one final state, Q2. That is subset equal to Q. That means you have taken the final state from Q only. So this is the definition of NFA. Finally, we end up with the definition of NFA. So this is what about the design of a NFA. Next, we will see some more examples on construction of NFAs. We will see another example. Design NFA that accepts strings which contains either 2 consecutive zeros or 2 consecutive ones. That means your string shall contain either continuously 2 zeros or 2 ones. Anything is accepted, either 2 zeros or 2 ones. So what will be the minimum string? The minimum string is either 0 0 or 1 1. That means we have to first of all draw the diagram for these minimum strings. After that, 1 0 0 is accepted, 0 1 1 is accepted, 1 1 0 is accepted, 0 0 1 is accepted. So that means there are 2 consecutive zeros. Here there are two consecutive ones, two consecutive ones, two consecutive zeros. So the minimum strings are 0, 0 and 1, 1. That we have to understand. First of all, we have to write the language of strings. Here the language of strings is 0, 0, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, 0, 1, 1. Like that you can write so many strings. So here there is no ending of the strings. You can have infinite number of strings. So that the language is infinite language. So what is the minimum length string? The language consisting of 0, 0, 1, 1, 0, 0, 1 or 1, 0, 0, 0, 1, 1 or 1, 0, 0. Like that you can write so many strings. Now you have to draw the diagram for this minimum strings. So how you will draw? On Q0, on taking 0, suppose that I am going to Q1. Again on taking 0, I am going to Q2. I am going to Q2. Now I am making this. Now I am making this as a final state. Suppose what about two consecutive ones? On Q0, if I receive 1, I am going to some Q3. Of that I am receiving again 1, I am going to Q4. Now I am making this as a final state. So this is the minimum string for the given diagram. Now I will write the possibilities. Suppose if I see 0, I will be on the Q0 only. If I see 1, I will be on the Q0 only. For some 1, 0, I am going to Q1. For some, again, on seeing 0, I am going to Q2. After seeing 0, 0, whatever may be either 0 or 1 comes, I will be on Q2 only. So here, as long as I will be on the state Q0 only. For some 1, I will go to Q2. Again, on 1, I am going to Q4. After that, it may be either 0 or 1. I will be on Q4 only. So now, this completes the diagram of NFA. So first of all, you have to draw the basic diagram for the minimum strings. And on Q0, I will be on Q0 and on Q0 with the 0 and 1, I will be on Q0 only. For some 0 and 0, I am going to Q1. For some 0, I am going to Q2. Similarly, I will be on Q0 only for 0 and 1. For some 1, I will coming to Q3. And again for 1, I am going to Q4. After seeing 1, 1, for zeros and 1s, I will be on Q4 only. Now, if you draw the transition table for this, the transition table for this is here. The input symbols are 0 and 1. Here this is sigma. This is Q0. So what are our states? Q0, Q1, Q2, Q3, Q4. Here Q4 is the final state and Q2 is the final state. So now you have to write all the transitions. On seeing 0 and Q0, where you are going? Either you are going to Q0 or Q1. On seeing 1 and Q0, you are going to either Q0 or you are going to Q3. This is Q3. On seeing 0 and Q1, you are going to Q2. On seeing 1 and Q1, there is no transition. On seeing 0 and Q0, you are going to Q2 only. On seeing 1 and Q2, you are going to Q2. On seeing 0 and Q3, you don't have any transitions. On seeing 1 and Q3, you are going to Q4. So on seeing 0 and Q4, you are going to Q4. On seeing 1 and Q2, you are going to Q4. So this is the transition table for the given NFA. Now we have to take strings and we have to see all possible ways whether the string is accepted by the NFA or not. Now we'll see whether the string is accepting by a NFA or not. First let us consider the string. let us consider a string w is equal to 1 0 1 0 0 1. Here you have two consecutive zeros so that it should be acceptable by the given NFA. Initially we'll start at Q0. First, what is the first input symbol? 1. On seeing 1, either you can go to Q0 or you can go to Q3. You have two possible paths. Either you can go to Q0 or you can go to Q3. Again, on seeing the next input symbol 0, first of all, if you go in this path, first of all, you have to select in one path and you have to travel in that path. And you have to come back and you have to go with the another path. So here, so again, what is the next symbol? Q0. Again, Q0 and 0 and Q0. Either you can go to Q0 or you can go to Q1. So here you have taken the next symbol. What is the next symbol? 1. So if you go in this path, 1 on Q0, you are going to Q0 or you are going to Q3. You are going to Q3. Next, 0 on Q0. 0 on Q0, either you can go to Q0 or you can go to Q1. You are go to Q1. Again, 0 on Q0, either you can go to Q0 or you can go to Q1. Again, 1 on Q0, 1 on Q0, you are going to Q0 or you are going to Q3. You have two possible states. Now again, after taking another 0 here, after taking another 0, if you come in this way, you are going to Q2. You are going to Q2. Again, on 1 on Q2, you are going to Q2 only. That means this path is leading to final state. Suppose if you come in this way, on applying 0 on Q1, you are going to Q2. You are going to Q2. Again, after applying 1 on Q2, you are going to Q2. That means here also you are settling at a final state. Suppose if you come in this way, here 1 0 1 1 0 1. Now you have 0. On applying 0 on Q3, there is no transition. So it is the path is terminated. Again, on applying 1 on Q1, here there is no transition 1 on Q1. Now again we'll come this way. Here, if you apply 0 on Q3, there is no path. 0 is no path. Now these two paths are leading to the final state. Now our string is accepted by the given NFA. Like that, you have to check all possible paths and you have to check whether the string is accepting by the given NFA or not. Let us suppose we will take another string L is equal to 0 1 0 1. So here we don't have two consecutive zeros or two consecutive ones. So it is not accepted. Now we have to check through the NFA diagram. Suppose you are at initial state Q0. On Q0, if you take 0, if you take the first symbol, either you can go to Q0 or you can go to Q1. Again, suppose if you go in this way, again 1 on Q0, either you can go to Q0, either you can go to Q0, here this is 1, or you can go to Q3. You can go to Q3. Again, what is the next symbol? 0. 0 on Q0 here. Either you can go to Q0 or you can go to Q1. Again on 1, either you can go to Q0 or you can go to Q3. Now the string is ended, but these two paths are not taken to final state. Now you come this way. 0, 1. On taking 1 and Q1, you don't have any state. Now here the state is terminated. Here, next one, on taking 0 on Q3, this is not accepted. There is no transition defined on Q3 with the symbol 0. Now if we come this way, so what happens? Next one is 0. Next one is 1 on Q1. 1 on Q1. Q on 1 is not defined on Q1. So this is also terminated. So now if you take only two ways, you are going to the some you are ending with Q0 and Q3. Out of these Q0 and Q3, none of the states is final state. So your string is not accepting. That means from the initial state, you are trying all possible ways. So none of the possible ways is leading to take us to the final state. So the DFE is not accepting the given string because the string is not containing either two zeros continuously or two ones continuously. I hope you are all understanding. Please watch the video again and again so that you will have clarity on NFAs. Thank you. Thank you for watching this video. Thank you all. Thank you for watching this video. If you really like this video, please subscribe, like, share, comment on my YouTube channel. In future, we are going to create many more videos on computer science engineering subjects. Thank you.